Hello everyone, welcome to Hudson Engineering Academy. It's me, your tutor Hudson, and today we're still going to continue on our lecture series, Principal Stresses and Strains, and we're solving problem number 4 on this particular case 4 that we learned in the previous video. We learned that when we have two mutually perpendicular stresses, and then we have shear stress, that is case number 4 according to the introduction that we did. Please watch that video. Then we have this question, and this question has been taken from one of the PYQ. We are a student of NIT Dogapu. You should be knowing that. At least if you check the PYQ, you'll get it. This is saying in a 2D solid body below, you're asked to determine the normal and shear stress on the inclined plane AB, then the principal stresses and associated planes, then maximum in-plane shear stress and its orientation. I will again put this particular question in the description of the video in case you can visit the question once again. So let's get to know what is given. We have sigma x, that is tensile because it's away from the member, it is given to be 50. Then we have sigma y, that is compressive. That means we're going to consider this value to be negative because it is what? It is compressive. And then we have tau xy, which is the same as tau yx, which is 25 Newton per millimeter square. So in case you have this member, how then can we solve this? Fine, let's have a look at how to solve the first part of the question that says find the normal and shear stress. To find normal, we learned that normal, sigma normal, is given by the formula sigma x plus sigma y, everything divided by 2, and then plus sigma x minus sigma y, everything divided by 2, and this one is having cos of 2 theta. And because we have also the component of shear, then this is plus tau sine of 2 theta. Well, this is what we have as the expression. So please, you have to learn this expression so that you can easily solve the question given. Now, sigma x is given to be 50. So we take here what? 50, and then plus sigma y is given to be 150, but it is compressive, meaning that we take that value to be negative 150. Take note of that, okay? Everything is out of 2, and then here is plus. We do the same. This is 50 minus sigma y is compressive, so it is taken as negative 150. Everything is divided by 2, then cos of 2 times. What is our theta? In this case, the angle inclined to the vertical, the oblique angle inclined to the vertical, is given directly, so no need to stress our mind. So we take our theta is 60. Okay, is 60. So this is for the first part. Then for the second part, we have tau. Tau is given to be 25. This is 25 sine of 2 times 60. Okay, quite easy, just like this. You feed this inside your calculator up to this, and then you add this to it. Definitely you'll come to a negative answer, and this is going to give you 78.35 in Newton per millimeter square. Okay, yes, because that is the unit given, so take note of the unit. Now the answer is coming to negative. Negative, once you get it, it simply means this sigma normal is what? Is compressive. Okay, is compressive. So you take note of that. Sigma normal is what? Compressive. Just like this one, which is compressive. So when you get negative, it means it's what? Compressive. Okay, so this is for sigma normal, which is for the normal what? Stress. Now we have to find for tangential what? Stress. So for the part of tangential stress, we say the expression is sigma t is equals to sigma x minus sigma y, everything divided by 2, and this side here is having sine of 2 theta. Now we have to take away, in the expression says minus tau cos of 2 theta. Okay, so we substitute this. Sigma t is going to be equals to, this is 50 minus sigma y, as I've told you, is minus 150. Okay, everything here is divided by 2. Sine of 2 times theta is 60. Okay? Then minus tau. Tau is 25 cos of 2 times 60. Okay? Just the same way. So feed this in your calculator. Then minus what? This one. And definitely the value is coming to positive 99.1 in Newton per millimeter square. See how easy it is. Now, since it is positive, that means this what? This answer or this stress is what? Is tensile in nature. Okay? So take note of that. So let's have a look at how can we solve the second part of the question, which is saying the principal stresses and associated planes. That is B part of the question. So let's start by getting the first one, which is the major principal stress. Sigma major is equals to, we learned that the formula is summation, sigma x plus sigma y, everything out of 2, then being connected by plus, then root of sigma x minus sigma y, everything divided by 2, here is squared, and then plus tau squared. Yes, so this is the formula. Now we got to substitute what we have. Sigma major is going to be equals to, sigma x is 50 and tensile means it is positive, then plus sigma y is compressive and that means it's going to be negative 150, everything out of 2, then plus root of, this is 50 minus, since this is compressive, so it is minus 150. Okay, and everything here is out of 2 plus, now this is tau square, that means it's going to be 25 what? Square. If you feed this inside your calculator, the value of this plus the value of this, sigma major is equals to 53.07. The unit is Newton per millimeter square. Okay, so this is the value we have obtained and it is positive. That means it is what? It is tensile. If we get negative, it means it is what? Compressive. So we're done with the first one. Let's get to sigma minor. Well, if this is the formula for sigma major, to get the sigma minor, I have to change this to minor and I have to change this what? This plus to minus. And this is the formula for finding the what? The sigma minor. So we have to substitute here. Sigma minor is going to be equals to same thing, 50 plus, this is minus 150 because it is compressive, everything is out of 2. Now the linking sign here is minus root of, this is 50 minus negative 150, everything here out of 2, and you square this bracket, and plus 25 square because that's the value of tau. Okay, so you got to feed this inside your calculator minus the result that you get from this under root. So what will you get? The value of sigma minor is coming to 153.08 in Newton per millimeter square, and this answer is negative. But instead of writing negative here, you can just write this and write that this one is compressive. Okay, well, as simple as that. Now you are done with getting the principal stresses. You have to find the associated what? Planes. To find the associated planes, we have to consider the formula that I gave you in the introduction, which is tan 2 theta p is given by the expression 2 tau out of sigma x minus sigma what? Y. So if you know this expression, you have to substitute and find the value of theta p. I want to remain with 2 theta P1. So this is going to be tan inverse because I'm taking tan this side. Okay. So of 2 times 50 times 25 mm divide by sigma x is 50 minus 150. Okay. Yes. So you realize that I can also take this 2 this side. Then I will get theta P1 here. Half tan inverse of 50 out of 200. Yes. So this is what we have. Now you're supposed to get the value of theta P1. Theta P1 is 7.018. This is in terms of degrees. Now, there is one expression that I told you previously that if I want to get theta P2, it's just a matter of considering theta P1 plus 90 degrees. Okay? So mean that the second angle, theta P2, simply is going to be equals to 7.018 plus 90. Then my answer is coming to theta P2 value is equals to 97.018 in terms of what? Degrees. So these are the associated what? Planes that you're supposed to get. We're done with B part of the question. We now need to do the C part of the question. To calculate the C part of the question, that is maximum in-plane shear stress, the expression is tau max is equals to, remember I gave the expression in the first video. Please watch that so that you know all these formulas. Half times what is inside the bracket is sigma y minus sigma x. Take note of that. Square. Okay. Plus 4 tau square. Very simple expression that you need to take. I have made it very clear. So tau max is therefore going to be equals to half root of, you have to substitute this. What is sigma y? Because it is compressive, it is taken as minus 150 minus sigma x, because it is tensile, it's taken as positive 50. Everything here is squared plus 4 times tau square. So this is 25 square. Okay? Remember, it is only tau which is squared, not 4. Now you got to feed this in your calculator and find the value of 103.08. This is Newton per millimeter square. Need to write correct units. Fine. We are done with getting the maximum in-plane shear stress. We now need its orientation. It is given by the expression tan 2 theta s is equals to sigma y minus sigma x out of 2 tau. You can realize the difference from the B part, the orientation of the B part. Okay? So we got to substitute this. If I take tan the other side, I'll remain this side with 2 theta s, let's call it s1. Okay? And this is tan inverse of, can you substitute this? Sigma y, because it is compressive, it's minus 150 minus sigma x, because it is tensile, it is positive 50. Everything is divided by 2 times 25. Okay? So you can also take this to the other side so that you only remain with theta s1. This is of tan inverse of tan inverse of what do we have up here? Minus 200 divided by positive 50. Okay. Well, so you can press this into your calculator and find the value of theta S1. Remember, since here was 2 theta S, that means you need two values of the what? Of the angle. And the easiest way is what I've shown you. You have to get the first one, then add 90 to it to get the what? The second one. Theta S1 is equals to negative 37.98. And this is degree. Now the thing is, if it is negative, what does it mean? This simply means that this is acting in a clockwise direction. Clockwise. Okay? Yes, so you need to take note of that. So you can just erase this negative and write a positive answer, but you put it up clockwise. But if you're calculating theta S2, theta S2 is equals to theta S1 plus 90, right? Good. So what takes place is that theta S2 is going to be, please, even if you had forgotten, if you had erased this, then you've written here clockwise. In your calculation, please carry that negative, so that this will be negative 37.98, then plus 90 degrees. So you got to add all these two answers. Then you get the value of theta S2. And this is supposed to give you something like 52.02. Yeah, something like that in terms of degrees. These are the two answers, and here is positive. It means it is acting anti-clockwise. Anti-clockwise. Well, so that is the end of the question. Thanks so much for watching this video till the end. Please, if you find the video helpful, do like the video, share with your friends, and above all, subscribe to this channel so that you don't miss any of my videos.